Introduction to nestjs. In the vast and ever-changing world of back-end development, one framework rises to bring order and structure. Nest.js is a progressive Node.js framework for building efficient, scalable, and maintainable server-side applications. It uses TypeScript as its primary language and takes inspiration from Angular's modular architecture, providing a highly organized and robust development experience. Designed with developer productivity in mind, Nest.js is perfect for REST APIs, GraphQL backends, WebSockets, microservices, and serverless applications. Its seamless integration with third-party libraries and its ability to adapt to various project sizes make it a favorite for modern developers. Why choose Nest.js? Why settle for ordinary when you can have extraordinary? Nest.js combines the best aspects of multiple frameworks. Scalability. Perfect for small apps and enterprise-grade solutions. Modular structure. Every feature is organized into modules, making it easier to maintain and expand your application. Decorator-powered design. Use decorators to declare routes, inject services, handle middleware, and configure guards. Dependency injection. Simplify sharing services and logic across your app. Multi-platform support. Easily switch between REST APIs, GraphQL, or microservices. Built-in tools. Comes with a powerful CLI for scaffolding, testing utilities, and runtime debugging. Setting up your first Nest.js application. To create your first Nest.js application, you'll use the nestjs CLI, which generates a boilerplate project with all the necessary files and configurations. Inside the generated project, you'll find a clean structure. Modules for grouping functionality. Controllers for handling incoming requests. Providers, services, for writing business logic. The CLI also simplifies common tasks, like creating modules, controllers, and services. For example, the command nest_generate_module users will create a pre-configured users module. The core concepts of Nest.js. Behind every great framework are solid foundations. Modules. These are the primary building blocks of a Nest.js application. Every feature or domain of your app, such as users or products, is encapsulated in its own module. You use the @module decorator to declare a module, where you define which controllers and providers, services, it includes. Controllers. Controllers are where incoming HTTP requests are handled. You use decorators like @controller to declare routes and @get, @post, and similar decorators to define HTTP methods. Think of controllers as the entry points for your app's logic. Providers, services. Services contain the business logic of your application. They are injected into controllers or other services using Nest.js's dependency injection system. You define a service with the @injectable decorator. Decorators. Nest.js relies heavily on decorators to make the code expressive and declarative. @module, used to define a module. @controller, marks a class as a controller. @injectable, declares a service that can be injected into other classes. @get, @post, @put, etc. maps HTTP methods to specific routes. Dependency injection. A powerful feature that allows you to share logic or services throughout your app. For example, you can inject a service into a controller to handle database operations or external API calls. Building a REST API. Let's create a RESTful experience. Building a REST API in Nest.js is intuitive and structured. Controllers handle HTTP requests. You use decorators like @get and @post to map routes to specific methods. These methods return the responses for the requests. Services are injected into controllers to handle the actual logic. For example, fetching data from a database or processing input from the user. DTOs, data transfer objects, are used to define the structure of data coming into your application. These classes help enforce validation and ensure that your API handles only valid input. Pipes allow you to validate and transform incoming data automatically. For instance, if a route expects an integer ID, a pipe can ensure that any invalid ID results in an error before the logic is executed. Middleware, guards, and interceptors. The secret sauce of Nest.js, middleware and utilities. Middleware intercepts requests before they reach a controller. This is perfect for logging, authentication checks, or modifying requests. You write middleware as functions or classes and apply them globally or to specific routes. Guards are used to implement authentication and authorization. They decide whether a request can proceed by evaluating its context, for example, verifying a token. A common decorator for guards is @useGuards. Interceptors transform requests or responses. They're ideal for logging, caching, or adding metadata to responses. Use the @useInterceptors decorator to apply them. Advanced features of nestjs. When your application needs to grow, nestjs has you covered. GraphQL integration. Nest.js provides seamless support for building GraphQL APIs. You can define queries, mutations, and subscriptions using the @resolver and @query decorators, microservices. For distributed systems, Nest.js has built-in support for microservices using transport layers like Redis, RabbitMQ, and gRPC. These services communicate efficiently and scale independently. Custom pipes and guards. Write custom pipes for advanced validation and guards for granular access control bot WebSockets. Build real-time applications with built-in WebSocket support. The @subscribe message decorator allows you to handle specific events. Testing in Nest.js. Good developers write code, great developers test it. Testing is straightforward in Nest.js, thanks to its modular design. Use the test utility to create testing modules, mocking dependencies as needed. Controllers and services can be tested in isolation by injecting mocked services. End-to-end testing ensures the entire application behaves as expected, testing all layers from routing to services and middleware. Best practices with Nest.js. Make your application a masterpiece. Use modules wisely. Group related functionality into feature modules. Avoid a monolithic app module. DTOs and validation. Always use DTOs to validate input and ensure consistency across your application. Custom decorators. Create your own decorators to encapsulate repetitive logic or enhance readability. Error handling. Implement global error filters to handle exceptions consistently and provide clear error messages. Leverage middleware and guards. Use middleware for cross-cutting concerns like logging and guards for secure authentication flows.